flash point of fuel oil number 6 is indeed listed in both NFPA 30 and NEC 2005 Article 500. In NFPA 30, fuel oil number 6 is listed within Table 4.1.1.2 as having a flash point of 150 degrees Fahrenheit, which is equivalent to 66 degrees Celsius. This table is typically found in the chapter that deals with general fire protection information and hazard classifications for flammable and combustible liquids. The flash point is a critical parameter for assessing the fire hazard associated with the fuel. It indicates the lowest temperature at which the liquid produces sufficient vapor to form an ignitable mixture in air near the surface of the liquid. For fuel oil number 6, this means that at or above 150 degrees Fahrenheit, a potential ignition source could cause a fire or explosion if the vapors are allowed to accumulate in a confined space. In NEC 2005 Article 500, fuel oil number 6 is also listed, but in Table 500.8c, with a flash point of 140 degrees Fahrenheit, which is equivalent to 60 degrees Celsius. This table is specifically related to the classification of hazardous locations, which are areas where fire or explosion hazards may exist due to flammable gases, vapors, liquids, combustible dusts, or ignitable fibers or flames. The difference in the flash point temperature between NFPA 30 and NEC 2005 might be due to the different testing methods, specific editions of the standards, or rounding conventions. Both values are close enough to indicate the general fire risk associated with fuel oil number 6. It's important to consult the most current editions of these standards for the most accurate and up-to-date information. The purpose of listing the flash point in these codes is to provide guidance for the safe handling, storage, and use of fuel oil number 6. It helps in determining the appropriate fire protection measures, electrical equipment requirements, and ventilation strategies to minimize the risk of fire and explosion in areas where this fuel is present. When working with fuel oil number 6, it is imperative to understand the flash point and other relevant properties of the fuel. This includes the auto-ignition temperature, which is the temperature at which the fuel will spontaneously ignite without an external ignition source, and the explosive limits, which define the range of fuel vapor concentrations in air that can result in a fire or explosion. The handling and storage of fuel oil number 6 should be in accordance with NFPA 30 and other applicable codes and standards. This includes using approved containers and storage tanks, providing adequate ventilation, eliminating ignition sources, and implementing fire suppression systems. In hazardous locations, electrical equipment must be properly classified and installed to prevent ignition of flammable vapors. This typically involves using explosion-proof or intrinsically safe equipment, as specified in the NEC. Regular inspections and maintenance are essential to ensure that all safety equipment is in good working order and that potential hazards are identified and addressed promptly. Training should be provided to personnel who handle fuel oil number 6 to ensure that they understand the risks involved and how to work safely with the fuel. This training should cover topics such as proper handling procedures, emergency response procedures, and the use of personal protective equipment. Fuel oil number 6 is a heavy, viscous fuel oil that is typically used in industrial and commercial applications. It is also known as bunker C fuel oil. Due to its high viscosity, it usually requires heating to be pumped and burned efficiently. The composition of fuel oil number 6 can vary depending on the source of the crude oil and the refining process. It typically contains a mixture of hydrocarbons, including paraffins, naphthenes, and aromatics, as well as small amounts of sulfur, nitrogen, and metals. The sulfur content of fuel oil number 6 can be relatively high, which can contribute to air pollution when it is burned. Regulations often limit the sulfur content of fuel oils to reduce emissions of sulfur dioxide, a major air pollutant. When handling fuel oil number 6, it is important to wear appropriate personal protective equipment, such as gloves, eye protection, and respiratory protection. This is to protect against exposure to the fuel and its vapors, which can be harmful to health. Spills of fuel oil number 6 should be cleaned up promptly to prevent contamination of soil and water. Absorbent materials can be used to soak up the spilled fuel, and the contaminated material should be disposed of properly. In the event of a fire involving fuel oil number 6, it is important to use appropriate fire suppression techniques. Water may not be effective in extinguishing a fuel oil fire, as it can spread the fuel and increase the size of the fire. Foam extinguishers are typically used to smother the fire and prevent reignition. Understanding the properties and hazards of fuel oil number 6 is essential for ensuring its safe handling, storage, and use. By following the guidelines and requirements of NFPA 30, NEC 2005, and other applicable codes and standards, it is possible to minimize the risk of fire, explosion, and environmental contamination. The flash point is a key property to consider when assessing the fire hazard associated with fuel oil number 6. The lower the flash point, the greater the risk of fire. Fuel oil number 6 is classified as a combustible liquid because its flash point is above 100 degrees Fahrenheit. Flammable liquids have flash points below 100 degrees Fahrenheit. The NEC defines hazardous locations based on the type of flammable or combustible material present, the likelihood of the material being present in ignitable concentrations, and the duration of the presence. Hazardous locations are classified into classes, divisions, and groups. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are those where combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 3 locations are those where ignitable fibers or flyings are present but not likely to be in suspension in the air in quantities sufficient to produce ignitable mixtures. Divisions indicate the likelihood of the hazardous material being present. Division 1 locations are those where the hazardous material is present under normal operating conditions, or where it is frequently present because of repair, maintenance, or leakage. Division 2 locations are those where the hazardous material is not normally present but may be present in the event of an accidental release or equipment failure. Groups are based on the specific type of hazardous material present. The NEC provides detailed requirements for the type of electrical equipment that can be used in each class, division, and group. These requirements are designed to prevent the ignition of flammable or combustible materials by electrical equipment. In locations where fuel oil number 6 is stored or handled, it is important to follow the requirements of the NEC for Class 1, Division 2 locations because the material has a flash print and may be accidentally released. This may include using explosion-proof or intrinsically safe electrical equipment, as well as providing adequate ventilation to prevent the accumulation of flammable vapors. Regular inspections and maintenance are essential to ensure that all electrical equipment is in good working order and that potential hazards are identified and addressed promptly. It is also important to train personnel who work in hazardous locations to understand the risks involved and how to work safely. This training should cover topics such as the classification of hazardous locations, the requirements for electrical equipment, and emergency response procedures. By following the requirements of the NEC and other applicable codes and standards, it is possible to minimize the risk of fire and explosion in hazardous locations. Remember to always consult the latest editions of the NFPA 30 and NEC for the most up-to-date information and requirements. Also, be aware of any local regulations that may apply to the handling and storage of fuel oil number 6. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. The selection of appropriate electrical equipment for hazardous locations requires careful consideration of the specific conditions at the site, including the type of hazardous material present, the likelihood of its presence, and the temperature and pressure. A qualified electrical engineer should be consulted to ensure that the equipment selected is suitable for the intended application and complies with all applicable codes and standards. The tables in NFPA 30 and NEC 2005 Article 500 provide valuable information for assessing the fire and explosion hazards associated with fuel oil number 6 and for selecting appropriate safety measures. By understanding the information in these tables and following the requirements of the codes and standards, it is possible to significantly reduce the risk of accidents and injuries. The use of appropriate fire suppression systems is also critical in areas where fuel oil number 6 is stored or handled. These systems should be designed to quickly detect and suppress fires, preventing them from spreading and causing significant damage. Fire suppression systems can include automatic sprinklers, foam systems, and dry chemical systems. The type of system that is most appropriate will depend on the specific conditions at the site and the nature of the fire hazard. Regular inspections and maintenance are essential to ensure that fire suppression systems are in good working order and that they will function properly in the event of a fire. It is also important to train personnel on how to use fire suppression systems and on emergency response procedures. In addition to fire suppression systems, other safety measures should be implemented to prevent fires and explosions. These measures can include controlling ignition sources, providing adequate ventilation, and implementing a hot work permit program. Ignition sources, such as open flames, sparks, and hot surfaces, should be carefully controlled in areas where fuel oil number 6 is stored or handled. Ventilation should be provided to prevent the accumulation of flammable vapors. A hot work permit program should be implemented to ensure that any hot work, such as welding or cutting, is performed safely. By implementing a comprehensive safety program that includes fire suppression systems, ignition source control, ventilation, and a hot work permit program, it is possible to significantly reduce the risk of fire and explosion in areas where fuel oil number 6 is stored or handled. Finally, it is important to remember that safety is everyone's responsibility. All personnel who work with fuel oil number 6 should be trained on the hazards of the fuel and on the safety procedures that must be followed. While working together and following the established safety procedures, it is possible to create a safe and healthy work environment.